And
This
thank
conference will now be recorded.
and thanks to everybody for joining us today for this Southern California sector specific outlook. I'm Andy Hoyle and I am at the NOAA Physical Sciences Laboratory. So I'll begin with a few slides about what our effort is all about. We're trying to modernize drought early warning, and we are piloting this effort over Southern California. Our vision is for drought resilience for the nation's economic sectors. And that's obviously a big and lofty goal, and we need to start somewhere. And we hope to do so by informing early warning and decision making based on co developed sector specific and evidence based drought intelligence. That's our mission. Our process is to pilot this effort over Southern California and to do so by delivering monthly sector specific drought scenarios based on integrated and tailored monitoring and forecasting information. So for the purposes of our effort here in our pilot, we are looking at Southern California only, and that includes Southern California counties with the exception of Kern County. And we want to call out that Southern California fits within the context of the greater water resources of the Southwest United States. So many of the perspectives that we'll show here include the Southwest as well. The sectors that we will focus on here today as part of this pilot are agriculture, water utilities, and public health. Obviously, some of the evidence that we will show spans beyond these sectors, but this is the principal focus of what we are going to address today and throughout this pilot. Our timeline will consist of solicitations, briefings, and summaries throughout the 2024 and 2025 Southern California wet season. So today is October 24th, 2024, and this is our first effort here. So today is our briefing, and tomorrow we will provide summary documents, as in a written document, and recordings of this presentation found on drought.gov at the QR code that you can see there. But this effort is really only possible with the collaboration and co-development with partners like you all, decision makers. And what we do ahead of this is to provide a solicitation for, or is there anything you're looking for? Should we watch out for something? It's something that you are specifically interested in. And that's going to happen 2 weeks before or the week before the briefing. We'll do this several times. Our next effort will take place at the end of November and early December. And we're doing that because of the holidays and try to combine efforts for November and December. We'll do it again in January, February, March, April, and May if conditions warrant that. Now, the sector-specific drought outlook briefing is going to consist of 3 parts. The first is a global perspective. What we're looking at here are conditions elsewhere in the Earth system that offer us some insights into Southern California weather and climate, and thus the sectors that we're looking at. The second is a regional perspective, where we're looking at the Southwest United States and conditions that are relevant to Southern California sectors. It's important to note that Southern California is intimately tied with water resources in the Southwest, so it's very important for us to take that perspective. And then finally, we'll get into each of the sectors that we're looking at and provide sector-specific drought outlooks. We're looking at water utilities, agriculture, and public health, and we will tackle those in that order. When we provide these scenarios, which are short statements that indicate what we think the most likely situation is to be relevant to each of these sectors, we're going to be providing a confidence statement. And these confidence statements are based on the IPCC confidence statements and how they define them. We'll assign high confidence, medium confidence, and low confidence. With high confidence, there's close agreement among several robust sources of evidence. Basically, we have that close agreement that gives us that high confidence. Finally, there's medium confidence. There's modest agreement among several robust sources of evidence. And then finally, with low confidence, we don't have a lot of agreement, and there isn't much for us to say about a given sector. So this month, we don't have any low confidence statements. They're all medium and high confidence. A thing to note here is that this is based on data that was available as of this morning, October 24th, 2024. So anything that's happened in the meantime will not be included in this presentation. Now, After I finish up a section of this presentation, what I will do is I'll ask our audience if there are any comments or questions. And I'll do so right now if there are any comments or clarifying statements that I can make to improve somebody's understanding. And one more thing to note is that folks can type in the chat box here. I can monitor the chat box to some degree. And if there's something that I can catch in real time and then be able to clarify a pointer or something other, then I'll try to be able to do that. All right, so where we begin with the global perspective is with a phenomenon called the El Nino Southern Oscillation. The El Nino Southern Oscillation is a wide-ranging phenomena that has global impacts, not just in the Southwest United States or Southern California, but globally. And for those who may be interested in this phenomena, it's composed of El Nino, La Nina, and neutral phases, and is related to weather anomalies that are used to predict conditions over California months to seasons in the future. And relevant to Southern California, in specifically this winter wet season, a weak to moderate La Nina is forecast to develop by late 2024 and persist into early 2025, which increases the chances for below average precipitation in Southern California. La Nina's effects are wide-ranging, and it is used as a source of predictability, meaning that because of its existence, we're able to say with some confidence what we think a future outcome will be. And we've gained this knowledge by looking at the relationship between precipitation, temperature, and other quantities, and La Nina events throughout our history. We also have other tools like forecast models that are able to help us be able to distinguish those effects. Relevant to the United States, the southern tier of the United States tends to be dry during La Nina events. That is, La Nina increases the chances of below average precipitation, really from Southern California through the southwestern United States into the southeast United States. Does this happen all the time? No, but it does increase the chances of such an outcome, that is, below average precipitation. And as a result of that, we use that as a source of predictability for future such seasons. Now, where we stand right now is in a situation called ENSO neutral. We are in neither El Nino nor La Nina. And we can monitor the El Nino Southern Oscillation in several different ways. And perhaps the most simple way is by taking sea surface temperature anomalies over the central tropical Pacific Ocean, which is shown right here. And if we look back in our history, back to last year, we had an El Nino event. And that El Nino event shows up nicely here, where we saw above average sea surface temperature anomalies in this Nino 3.4 region. Since then, what we've seen is a decline in sea surface temperature anomalies to the point that we are bordering on a La Nina situation, and that we are most likely under La Nina development right now. Now, as we look into the future, these are forecasts from the NOAA Climate Prediction Center, which quantify the likelihoods of La Nina, ENSO neutral, and El Nino for future 3-month seasons, beginning in September, October, November, where we stand right now, and going all the way through May, June, and July of next year. And as you can see, La Nina is the most likely outcome as we move toward winter and into early next year, at the likelihood of about a 75% chance for November, December, and January, which is why we are anticipating the development of La Nina and therefore anticipating the effects of La Nina over the southwest United States and Southern California. One aspect of the climate system that we also need to call out is something called the Madden-Julian Oscillation. So the Madden-Julian Oscillation is composed of 8 phases as it moves through the Indo-Pacific, and it's related to weather anomalies that are used to predict conditions in California several weeks into the future. So this is relevant in situations like where we're at right now because an event is underway, which in that event is decreasing the chances of a precipitation event in California through the first week of November. So this chart right here indicates what tends to happen during what we call MJO phase 6. So MJO means the Madden-Julian Oscillation. So we are currently in the Madden-Julian Oscillation phase 6, and we're forecast to be so over the next few weeks. And as a result of that, we are anticipating decreased atmospheric river activity in California, in Southern California. And as a result of that, we are not expecting to see much precipitation over the next few weeks in California and Southern California. So the Madden-Julian Oscillation is a proximate cause of the weather variability that we see over California and is related to below average precipitation. And we are forecast to see such an outcome over the next few weeks. So essentially dry conditions over the next few weeks over California and Southern California. So before I move into the regional perspective, are there any comments or questions from our audience? All right, well, hearing none, we'll move on here to the regional perspective that quantifies the current situation of drought over the Southwest United States. The first point here is that the area in drought increased in the Southwest United States and Southern California during summer 2024. And the reason for this were some extreme weather and climate anomalies that we saw over this region of the world. And these extreme climate anomalies were historically low precipitation and historically warm temperatures, leading to soil moisture declines. And the third point here about the current situation is that reservoir levels remain near and above average, though groundwater generally remains low due to decades of drought and pumping. The important thing to note here is that reservoir levels, they're very sensitive to precipitation during the prior wet season, or if you're within a wet season. And because we are just beginning a wet season right now, we're reaping the benefits of above average precipitation over the last 2 years. So reservoirs, they're not a concern, at least in this moment, because of their average and above average situation. However, drought has developed in California and the Southwest US during the summer of 2024. And really the easiest way to look at this here is through the US Drought Monitor as of the October 22nd, and this was released this morning, the 24th. And noting that in the Southwest United States, we've seen abnormally dry conditions span almost the entire region, but deeper aspects of drought, like moderate drought, severe drought, overspread areas in southeastern California, western Arizona, and southwestern Utah. We're also seeing some extreme drought elsewhere in Colorado and New Mexico. And this has really been a recent appearance of drought because of those extreme anomalies that I was talking about before. So on the right is the US Drought Monitor change over the last 12 weeks. So this compares October 22nd to July 30th. And you note there that the change or the class degradation, so those deeper brown colors, they closely map what the US Drought Monitor looks like today. It indicates that this drought has really come on in the last 3 months over Southern California and the Southwest US. Now, looking at soil moisture here, during the summertime, when we see these extreme anomalies, low precipitation, high temperatures, especially related to the North American monsoon, the effects of drought are most readily found in soil moisture. And that's what's being shown here. So these are soil moisture percentiles on the 19th of October of 2024, so just a few days ago. And the deeper red colors indicate very low soil moisture values that have popped up across much of the southwestern United States in those same areas generally that the US Drought Monitor is indicating. And you can see a pretty large expansive drought in the central United States as well. Now, the reason for this and low soil moisture values, and thus the US Drought Monitor depiction of drought, were because of anomalous conditions during June, July, and August. And looking here at southwestern United States and southeastern California, what we noted here is the driest such season on record and near the driest such season in other areas spanning that driest area. That's because of a poor monsoon performance in those regions. And also noting here on the right is this is temperature anomalies. The deepest red color indicates the warmest season on record for June to August 2024 in the 130-year history that is considered here. So noting that we have seen compound dryness and heat over the Southwest, that's really led to the situation that we're in right now in terms of drought. Now, like I said before, reservoir levels tend to be tied pretty closely to the wet season, the principal source of water in the form of precipitation. And what we're noting here is of the 23rd of October, that reservoir storage throughout California is at near average levels and even above average levels in some areas. So this spans like Lake Cachuma, for instance, all the way down to areas in San Diego. So conditions there are not too much of a concern at the moment. What's more of a concern for reservoirs, at least for now, is what the forecast precipitation is to be during the winter season. On the right is groundwater level percentiles. And over Southern California, seeing a pretty mixed performance there. The reason there is that over the last few decades, water resources haven't been plentiful because there's been more dry seasons than wet seasons. And as a result of that, there's been a lot of use of those groundwater resources. Now, snowpack development right now isn't that much of a factor. Snowpack development right now, it's too early in the season to really get concerned about this. But I just wanted to include this here because this is something that we'll see time and again, and this is from USDA's NRCS. We do note that at least in these southern portions of the Rockies in the southwestern United States, seeing really high values for this time of year, that's because of a storm that came through last weekend. Now, getting into forecasts relevant to drought and, of course, the sectors that we're looking at, three main points here. Number one is that the Southwest U.S. area in drought is expected to increase by the end of January of 2025, according to the NOAA Climate Prediction Center. The second point here is that forecasts indicate increased chances of below average precipitation through March of 2025 in the Southwest U.S. And these forecasts here are really the basis for NOAA Climate Prediction Center's outlooks. And then finally, three, forecasts indicate that above average temperatures are most likely across the U.S., with up to a 70% chance of such an occurrence. This plot right here indicates the seasonal drought outlook from NOAA's Climate Prediction Center. Those deep brown colors indicate where drought is currently ongoing right now at the date of release, which was last week. The yellow colors indicate likely areas of drought development. So interpreting this map at the 1,000-foot level would indicate that by the end of January, the entirety of the Southwest United States will be, or almost the entirety, will be under drought. And the forecast there, we'll get into that in a little bit more about the reasoning behind it. Now, these are also forecasts from the Climate Prediction Center, which are probabilistic in nature. And what they indicate is the probability of above average temperatures, that's on the left for November, December, January, and on the right is precipitation also for November, December, January. Now, indicating that there is an increased likelihood of above average temperatures across much of the Southwest, which is consistent with our reality in terms of temperatures in the recent decades compared to those in the past. And on the right is the seasonal precipitation outlook, which indicates a tilt in the odds or an increased chance of below average precipitation over much of the Southwest. This below average precipitation area only marginally gets into Southern California. And the reason for that is in part due to the behavior of this La Nina event or impending La Nina event, which is weak in variety, but also doesn't have as much of an impact on Southern California during November, December, January, as it does in, say, January, February, and March. And that'll become clear in a few slides. This right here are model forecasts. So this is from a forecast system that we call the North American Multi-Model Ensemble. It displays more or less the same information that was shown previously. That is the likelihoods and the chances of above average temperature, below average temperature, and near average temperature on the left, in the same perspective, but for precipitation on the right. Indicating for November, December, January, increased odds of above average temperatures in the Southwest and in Southern California, and a tilt in the odds or slight increase in the chances of below average precipitation over the Southwest, the proximate cause of that being La Nina within these forecast systems. Now, moving into January, February, and March, which is the all-important critical time of year in the wet season for Southern California, noting that temperatures are forecast to be above average with a pretty high likelihood, at least from this forecast system, of about 70% chance. And on the right, in terms of precipitation, noting a greater than 40% chance of below average precipitation. So one thing to note here is that below average and above average are defined by the upper and lower thirds of the historical distribution, respectively. So a 40% chance of below average precipitation is an increase in the likelihood of such an occurrence. So that is one thing to note in how to interpret these probabilities compared to otherwise. Now, before I get into water utilities and the remaining sectors, are there any comments or questions about the current state of drought and forecast drought over the next several months?
So should I just jump in?
Jump right in, Roger. I can see you.
Okay, so did I hear that this is a slight La Nina
Yeah, this is a weak one.
versus
Yeah,
a weak one?
yeah.
Are there, like on the previous slides, are there comparisons between what a slight La Nina would look like versus a full-on La Nina?
You're
The
foreshadowing.
impacts.
You're foreshadowing the next slide, actually.
Okay, I'll sit back and wait.
Yeah, well, thank you very much. Yeah, that's a really good question, and it's right here, actually. So it'll probably be better address your question after we finish up with this section here, after we're able to talk about the differences between moderate La Ninas and weak La Ninas. So what's shown here is the relative risk of having dry conditions that's below average or wet conditions above average compared to climatology during a moderate La Nina and a weak La Nina. So this is expressed not in terms of probabilities, but in risk. And the way this is done is by computing the frequency of below average precipitation during a moderate La Nina, and then comparing that to the frequency of below average precipitation when you don't have a moderate La Nina. And the same goes for weak La Ninas on the right, where you just simply compute the frequency of below average precipitation during weak La Ninas, and then compare that to the frequency of below average precipitation during other years. And what we can see here is that during moderate La Ninas, we get up to a 2.5-fold increase in the risk of below average precipitation across the southwest United States and, of course, southeastern California as well. Now, during weak La Ninas, we don't have as much of an increase in the risk. We do have up to a 2-fold increase in the risk of below average precipitation, but it's more scattered in terms of its spatial pattern, and it really is not as strong in terms of a shift in the risk as a moderate La Nina. So moderate La Ninas tend to produce a more reliable impact on Southern California and the Southwest than do weak La Ninas. Now, we repeated that analysis, but instead of doing it for just above and below average precipitation, which are defined by the upper and lower thirds of what we've seen in history, we've looked at this here in terms of extreme low and high precipitation. So extremes here are taken as the upper and lower 20th percentile of a historical distribution, so the quintiles. During moderate La Ninas, we get up to a 3-fold increase in the risk of extreme dry conditions over the southwestern United States and those areas in southeastern California. Weak La Ninas, on the other hand, don't produce as much of an effect. They do produce an effect of up to a 2.5-fold increase in the risk of extreme low precipitation over southeastern California, and maybe a hint of that over the rest of the southwestern United States, but certainly not to the degree that we tend to see during a moderate La Nina. So there is a pretty distinct comparison and a pretty distinct difference between moderate La Ninas and weak La Ninas in terms of their precipitation effects over the southwest and southern California. Now, in terms of snowpack, which is critically important here to water resources, what we want to illustrate here is that La Nina events, they decrease. They are related to a decrease in the amount of snowpack on the 1st of April. So the amount of snow water equivalent on the 1st of April that is able to run off into rivers and then move into reservoirs to be captured later for use. 2018, 21, 22, 2023 are shown here because they're the last 4 La Nina events. And you could repeat the same analysis that I showed previously here for snowpack, and we hope to do that next month in terms of snow water equivalent. But one thing to note here is that there is a distinct influence and a distinct relationship between low snowpack and low snow water equivalent on the 1st of April related to La Nina events. And you can see that during 3 of the last 4 La Nina events. 2023, on the other hand, was an interesting one. It was also a weak La Nina, and it was related to quite above average snow water equivalent on that all important April 1st. So from there, what we were able to do, noting forecasts of temperature, precipitation, noting forecasts from collaborators like the Climate Prediction Center, and the analyses related to La Nina, that is precipitation and snow water equivalent, we're able to put together this scenario here. And we're able to say reservoir storage is generally near average in Southern California, as we noted, but it's expected to be lower in October 2025 compared to that in October of 2024. We get medium confidence in this, given how we would anticipate the climate system to play out. The supporting evidence here is that we have an elevated risk of below average precipitation in the 2024-2025 wet season, below average snow water equivalent in spring 2025, given La Nina, and above average temperatures. Groundwater levels remain a concern. Several areas in Southern California are reporting low groundwater, and then chances of recharge are low through October of 2025 due to forecast below average precipitation amid continued use. So that finishes up our section on water utilities and this scenario. Are there any comments or questions? Did I address everything that you were thinking of, Roger?
Um, yeah, I think so. And I just started typing a question into the chat, but maybe I'll just ask it out loud. So, with a changing climate, how confident are we that future La Nina and El Nino situations will produce the same results as they did in the past?
Yeah,
So, in
that's
other words, could it be really crazy and what we see in the past not even be what's in the future?
um,
Um,
I think that we do have tools at our disposal, whether it's observations or weather and climate models, to be able to suss that out, to be able to compare conditions in a recent climate to those in the past, and be able to determine what the effect of La Nina would be on snowpack on April 1. That is playing out in the science right now. So, probably a little bit too premature to be able to bring this into our framework today. But I assure you, that kind of work is being done.
okay, 'cause what's ringing in my head is the past not predicting the future with climate change. So, but if folks are working on it, that makes me feel better.
Yeah. This is a very important topic for us in several different ways. All right. Well, thank you very much, Roger. And again, if anybody has any comments or questions, feel free to make them. All right, and moving on here to our agriculture sector. The majority of Southern California is in plant zones 8 to 10 as defined by U.S. Department of Agriculture. And this is based on the average annual extreme minimum temperatures during 1991 to 2020. You can see that here where temperatures, they can get down and be below freezing in the southwestern United States and Southern California. On the left here are the counties that we're focusing on and the polygon shown for the agricultural areas, which are pretty rich and take up a majority of that region. Now, what we're looking at here for the next several months, and this is for October of 2024 to March of 2025, is low soil moisture to build into the Southwest United States and to Southeastern California. So this is a prediction produced by the NOAA Climate Prediction Center in an experimental sense, and they were nice enough to allow us to use this today. And noting here that widespread soil moisture below the 30th percentile and even below the 20th and 10th percentile in many of those southwestern United States areas. And that really follows along with the forecast precipitation and temperature over the next several months, combined with what we're seeing today. What this here is, it's Southern California precipitation averaged over the counties that we're focusing on and shown in a cumulative sense. So you can think of this as that for the 1951 to 2023 period, you can show cumulative precipitation for each and every year. So instead of showing each of the traces for those years, we've shown this in terms of percentiles here to highlight where in the distribution that we fall. Most important thing to note here is that the principal wet season here is really December into March for Southern California, and that there is a huge range of possible outcomes by the end of the wet season. That is, the lowest season on record, which was in the 1970s, was at just about 80 millimeters, whereas the highest precipitation season on record was around 500 millimeters. So that's a huge range and really is something that sets California and Southern California apart from just about every part of the globe. And the reason for this is because of the frequency and intensity of just a few storms that come through the region, as in the precipitation accumulates in bursts. Now, with this perspective right here, what this shows is daily precipitation counts for October to September, exceeding certain thresholds, 1 millimeter, 5 millimeters, and 10 millimeters. And what we did here was to separate this into several different bins. The first is for the entire period of record, which spans 1951 to 2023. The second is for years since 2000, so 2000 to 2023. Then we selected moderate La Nina years and weak La Nina years. And the bars indicate the average of all those years that meet the criteria. And the whiskers, so those lines, they are the range of possible outcomes during all those years. So for instance, during a moderate La Nina event, when we see a 5 millimeter threshold, on average that happens about 8 days a year. And the range around that is about 5 to 12 days a year. But when we look at that right here, we see that during La Ninas and weak La Ninas, we tend to get fewer precipitation days and fewer precipitation days meeting those really high thresholds, those really strong storms that bring substantial accumulation into Southern California. So this is part and parcel with the pictures that I was showing before, which indicate below average precipitation being most likely during La Nina and weak La Nina events. Now, minimum temperatures are important to agriculture because of below freezing temperatures that lead to damage to vegetation. And we tend to see those during November through early March. So taking the same perspective as we had before, which takes daily minimum temperatures and then shows the distribution of that throughout the seasonal cycle. So those lowest temperatures that we can see tend to happen between November and early in March. Now, one thing to note here is that we tend to see cold air outbreaks during La Nina events and weak La Nina events. That is, cold air intrusions that lead to very cold temperatures across the United States and Southern California. And La Nina increases the likelihood of that. And to some degree, we're seeing that right here. So using the same perspective as I was shown previously, that looking at temperatures falling below 3 Celsius, 0 Celsius freezing, or a killing freeze, -3 Celsius in Southern California during each of these criteria. That is all years since 1951, years since 2000, and La Nina and weak La Nina events. So just focusing here on below freezing temperatures, on average, they tend to happen about 5 times a year when averaged over the entirety of Southern California. But the range around them can actually be rather large. So they can range between about no time, not happening at all, up until about 12, 13 times a year. So there's a big range. But what we do see is that during La Nina events, we tend to see an increased frequency of them. And there's a suggestion of that here in these pictures. Now, also focusing on maximum temperatures. So maximum temperatures, we don't have to focus on for several months now, although it is a warm time of year here toward the end of October. We'd really be looking more along the lines of June, July, and August for for affecting vegetation and also impeding in the ability of workers to go out in the field just because those temperatures would be harmful to them. But really that June to October timeframe is the most important time. And noting here that since 2000 or a more contemporary climate, what we tend to see is a much higher likelihood of daily maximum temperatures exceeding thresholds of like 36 degrees Celsius and 38 degrees Celsius over Southern California. And that's just, again, the reality of the situation in terms of warmer conditions over the last few decades compared to those prior. So we'll be looking ahead to that as we move ahead into the next warm season, so next year. So from that, able to produce a agricultural scenario, and it reads, crop stress, which may reduce agricultural productivity, is expected through spring of 2025 in Southern California due to forecast below average precipitation and the possibility of below freezing temperatures. We have medium confidence in that. The supporting evidence here is that La Nina, which is forecast from late 2024 through early 2025, is related to below average precipitation in Southern California due to fewer, heavier precipitation days. And then La Nina is also related to cold air outbreaks in the United States that leads to below freezing temperatures in Southern California. So that is our agriculture scenario and our evidence for it. Are there any comments or questions?
Hey, Andy, there's one in the chat. Are you including La Nina and weak La Nina events since 1951 or since 2000?
Since 1951. Annie, you can jump on if you'd like.
That answered my question. Thanks.
Oh, thank you. All right. Well, thank you for your question, Annie. So let's move on to the public health sector right now. Now, where we stand right now is we have several active wildland fires burning in Southern California. And as a result of that, we're seeing moderate to unhealthy for sensitive groups air quality. This map right here, which was taken this morning, shows a wide area of moderate air quality in the vicinity of those fires. And I've been following this for several weeks now. And this is actually one of the more optimistic air quality reports, where sometimes we've seen several areas with unhealthy for sensitive groups. But nonetheless, wildfires burning in Southern California, reducing air quality. And also with the really dry conditions that we've seen over Southern California, there's certainly a risk of wildfires breaking out and spreading across the region through October and into November. One thing to note also is that wildfire seasons are becoming longer in the recent few decades compared to the decades prior to that. So this also increases the risk of effects on people because of the prolonging wildfire season. Now, a couple things that we're going to be looking at here for Southern California are relevant to the movement of dust. And what's shown here is daily average wind speed for Southern California. So this spans October through September. And what we note here is that there can be a wide range of possible outcomes on a given day related to wind speeds. But one thing to note is that during springtime, generally March to June, maybe an extended springtime season, that we tend to see the highest winds and the highest wind magnitudes in Southern California. And taking the same perspective that was shown previously, what we've done here is to identify wind speeds exceeding 3 meters per second on a given day, and then look at the direction where that wind was coming from, whether it's to the north, to the east, to the south, and the west. So what north means is a wind that blows from north to south. East means a wind that blows from east to west. South means a wind that blows from south to north. And west means a wind that blows from west to east. What's noteworthy here is that windy days are predominantly related to winds out of the west. That happens about 15 times per year. And there is some spread around that, which spans nominally about 11 days per year, maybe up into the early 20s or so. There isn't a distinction between windy days that with La Nina, weak La Nina, and all the other occurrences, say between 1951 and 2023. So it doesn't appear that La Nina, which would be ongoing at this time and waning, would have an effect. But nonetheless, we tend to see windy days each year with winds out of the west and out of the north. I showed this plot previously, but it's important to note that we don't have as many heavy precipitation days in Southern California related to La Nina and weak La Nina, which is what we're expecting here. So we would expect a dry land surface, and that's consistent with several of the forecasts that I showed previously. And as winds blow across these areas where that can be sources of dust, that would lead to particulate matter in the air that would reduce air quality and lead to some effects on people. So a public health scenario was created. And what we've noted here is that intermittent poor air quality is expected during fall 2024 and spring 2025 in Southern California. That's with high confidence. And the supporting evidence here is that in fall 2024, air quality will likely be reduced by smoke from wildland fires burning in the Southwest United States, And then in spring 2025, air quality will likely be reduced by airborne particulates due to intermittent strong winds from the north and west blowing over the dry land surface caused by below average precipitation during the 2024-2025 wet season. So that finishes up our public health scenario. Are there any questions? I see a hand is raised, so please go ahead.
Hi, can you hear me?
Yes, I can hear you.
Hi, this is Michael Castro from Riverside County. I'm wondering if there's any intention to also make predictions or potential guesses as to how this affects our future wildfire seasons as well. If this has any known implications, or is that not something being accounted for yet?
So you mean by future wildfire seasons like next year's wildfire seasons?
Right. So a drought being the foundation for a more aggressive and intense than on average wildfire season, based on drought towards the our immense ecosystem.
Yeah, that's a great question. And La Nina events during fall and winter, they actually are related to an increased risk of wildfire occurrence in Southern California and Southwest United States during the following spring and summer season. So yeah, you're entirely right. And we could actually add to this public health scenario with that information because there is research to support that.
Thank you.
Yeah, thank you. So Joe Casola has his hand raised. Joe, go ahead.
Thanks, Andy. I really like all the probabilistic information that you guys are putting out. I'm very curious to see how kind of the different practitioners might see value, but some of these are kind of novel depictions. I think they're really cool. I actually have a question for the public health folks, and given how hot and dry things have been and relatively busy fire season, have there been a lot of air quality issues kind of brought to your guys' attention, like either at the city or county level, where folks have said, oh yeah, things are really, really bad? Or is it just kind of like, yeah, this is just summer in Southern California now?
I see Juan had raised their hand, so please go ahead.
Yeah, so I'm the director of our climate program with Riverside County, and one of the big things we're hearing from community members is issues around air quality, initially associated with Tropical Storm Hillary, but overall, I think they look for a scenario to blame the bad air quality on, and it may not necessarily be Hillary, but there are a lot of conversations happening around the increasingly bad air quality in Southern California, especially from community organizations and some of the bigger health systems too.
Yeah, thanks, Juan. And where I was going with this, and where I was curious about it, Andy, is would you be interested in dabbling with what would be the timing of early fall significant rain? So kind of when might you get some rain to clean the air? And this gets away from seasonal forecasting, right? We'd probably be more at the, let's say 2 weeks out, perhaps, thinking of how some of the AR forecasts work. But I'm curious if something like that would be helpful, if you could kind of create an expectation for the public health folks to say, oh, okay, yeah, we should expect the next 2 weeks it's going to stay bad. Sorry, everybody. Or no, actually, we're starting to see some chances of some rainfall. We might get a little respite from all the dust and the smoke and the particulates.
Yeah, that's a great point. And I think we can say that because there is some confidence in the forecast for the next few weeks. And I alluded to that with the Madden-Julian oscillation behavior and the forecast precipitation through roughly the second week of November. So I think we can add that as well. And I think these are two important points to add: the timing of significant rainfall, and also what we can say about future wildfire seasons, because I think we do have some information to support that right now. I saw a question here in the chat box. It's from Andy. Is it possible to add a dust storm forecast? I think dust aerosols from the Salton Sea are of concern in Southern California. I'd need to go check on that. If somebody has a source for dust storm forecasts in Southern California that I'm not aware of, please chime in. But yeah, that's something that we can look into.
There's a local Bureau of Reclamation contact that I can put you in touch with that's in charge of the Salton Sea restoration efforts, and he's probably your best contact.
Excellent. Thank you, Roger. Yeah, thank you everybody for the comments and the participation. Are there any remaining comments that we didn't address, or some questions that folks might have?
If not, Andy, I can move over to the Google form if you'd like.
Yeah, go ahead.
Yeah. So just to close out here, I think we were getting to hear some of the questions, especially in the public health piece, where we're obviously thinking about what to keep providing you guys and involve this. Obviously, as we move through the season, some of that will be determined by the conditions, the monitoring, what forecast information, climatological information is available. But some of that's just making sure we're tailoring better and better to what you guys want to see and hear. And so every time we do one of these, a week or two beforehand, we'll be reaching out to ask, hey, what is some of those things you're especially thinking about, perhaps for the next one? But we did create a quick poll here. There's a Google form link in the chat that if you're interested in, we would like to hear a little bit what you gained from today. What was it? What you expect to see? What would you have liked to have seen? Even as much as say, hey, I hated this slide, or I wanted to have it presented this way, or were we missing a data set or something you wanted to see? So in the last few minutes here, we would welcome if you want to fill that form out. It would help us improve these for next time, as well as keep just making sure we can give you guys the best information available, so you guys can actually use it as much as you can. Andy, do you have anything else you wanted to add?
No, I don't have anything else, and just thank everybody for attending and for contributing.
And someone just commented they can't open the Google Forms at their organization, so I will send those separately to you guys, so you'll be able to fill them in. So, and the next one of these is scheduled for Thursday, December 5th, so we'll probably, because of the Thanksgiving holiday, we'll reach out a little bit before Thanksgiving to be like, hey, what are you thinking about some of these things, considerations? And even, Andy, we're talking about what we'll have will evolve over time a little bit, because December is a lot different than, say, October, with what we may have be able to pull from in there and things like that. So we will send all this out tomorrow, but then continue to tell us, fill out the form, reach out to Andy and I if you have any feedback or things you'd like to see. Otherwise, we'll reach out again come late November as well.
Hey, Amanda, I think there might be a problem on the Google form on the back end. It might be accessible only to NOAA folks.
Okay.
So see if we could flip that switch really fast so folks might be able to fill it out now.
I know the CDPH folks, it's an internal thing for them.
Okay.
Yeah, if those are the only two that had trouble, that's a thing for them.
Great.
Double check here.
I can get to it.
Okay, great. Good. Well, not good for CDPH, but we'll get.
We'll make sure they get them sent separately. So.